There we go. Okay. So in the last video you guys had to watch for Thursday, we were doing evaluation theorem, which is part of the fundamental theorem of calculus. Basically, you find the antiderivative and then you evaluate it. You plug numbers in and you find the area underneath the curve. Well, today we're doing the same, but we're going to find the average value of a function on an interval underneath a given function or a curve. So the formula is the same as last lesson, but we have one new addition. To find the average value, you now have 1 over b minus a times the integral from a to b of f of x dx, which will then give you 1 over b minus a times the antiderivative evaluated from b to a, and then we just plug in the numbers and evaluate. So we definitely will be using Desmos today to help us out. Oops. Okay. Down below are just the integral formulas, just to help us out if we need them. There's one new integral formula on here, and that's this guy. Oops. And that's this one. So it says the integral of e to the ax dx will be equal to 1 over a times e to the ax plus c. So we'll be using that in one of the problems later on. Everything else is still the same. Power rule's your best friend. The antiderivative for e to the x, 1 over x, all of those formulas still apply. Okay, so let's go ahead and start working the examples. Okay, number 1. Find the average value of the given functions on the given interval and graph the function and its average value over the indicated interval. So we're going to find the antiderivative, evaluate it, and then we're going to graph it. Okay. So let's go ahead and set up our average value integral. And to get started, the interval is going to be labeled as a and b. Okay. So now when we start the average value formula above, we are going to get 1 over b minus a, which is 5 minus 0, times the integral from 0 to 5 of the function 2x plus 7 with respect to x. Okay. And now the integral is set up. Let's go ahead and clean this up. You'll get 1/5. And now we are actually ready to find the antiderivative of this integral. So I'll just put brackets here to be neat. And we're going to take the antiderivative of 2x, which is going to be 2 times x squared over 2, plus the antiderivative of 7. And the antiderivative of 7 is just 7x. And we will evaluate this from 0 to 5. Okay, nothing new. The only thing new is this fraction in front. That's it. Okay, clean it up a little bit more, and we'll get 1/5 times x squared plus 7x evaluated from 0 to 5. Everything's nice and cleaned up. Go ahead and plug in 5. Go ahead and plug in 0. So this is what we're going to get. 1/5 times, and I'm going to plug in 5. You get 5 squared plus 7 times 5 minus, and put a parentheses here, and you'll have 0 squared plus 7 times 0. Close bracket. Okay. Well, that 1/5 stays there, and you're going to get 5 squared, which is 25, plus 7 times 5, which is 35. Oops. And guess what? All of that just becomes 0. So you get 1/5 times 25 plus 35, and that'll give you 1/5 times 60, which happens to be 12. This is the average value of that integral on that interval 0 to 5. So that would also be the average value of the area underneath that curve. Okay, so we found all of that, and now we have to graph it. So what we're going to do here is, of course, use Desmos. We're going to make your life easier, or I'm going to make your life easier, right? So let me go ahead and pull up Desmos. And let me start. I need the new, I don't need that one. Graphing calculator. And also to make you guys' life easy, so you don't have to do all of this. I'm just doing that to show you how everything works. Now, since we're using Desmos, this is what you guys are going to type in. It's going to be the 1/5 times the integral from 0 to 5 of 2x plus 7 dx. So this is exactly what you will type in Desmos. And let's see. I'm going to do that. So you get 1/5 times the integral from 0 to 5 of 2x plus 7, and then with respect to x, and there it is, 12. Life is great, guys. Okay. We're still going to graph it, but before we move on, what I do want you guys to show, at least have something for shown work instead of just giving me an answer, at least get to this step right here. That's good enough for shown work. And then you can just say that equals 12. That's it. That's all I ask. At least put a little bit of effort in, right? Okay. Now let's go ahead and graph this function. So I'm going to say graph, and we're graphing y equals 2x plus 7. Okay. So here I'll make a nice little graph, and it's giving us the x values already. It says we're graphing this from 0 to 5. So here's 0, and then 1, 2, 3, 4, 5. And now what's beautiful about Desmos is I'll just type in the regular function 2x plus 7, and then I'll use that XY chart, and I'm going to type in those numbers 0, 1, 2, 3, 4, and 5. And we go 7 to 17. So this will be 7, 9, 11, 13, 15, 17. So I'll just say 7 and 17. And when I graph this, we'll be at 0, 7. You'll be at 1, 9. And this just keeps going up to the right. So our graph would look like that. Okay. Now the last piece to graph is the actual average value. So the average value is going to be understood as a horizontal line as y equals 12. And all we have to do is plot that on the graph. So there's 7, 9, 11. So here's 11 and 13. So right here would be our average value of y equals 12. And that's it. That's all we have to do for that one. So any questions on that process?
No, sir.
All right, good. Okay, let's keep moving then. All right, 2. Find the average value of x minus 3x squared on the interval -1 to 2. So again, let's set up our integral. Here's a, here's b. So we're going to get 1 over b minus a times the integral from a to b, can't say b, a to b of the function x minus 3x squared dx. Okay, there's our integral. It's set up. Let's go ahead and find the antiderivative already. Okay, for the fraction, 1 over 2 minus minus 1, well, minus minus becomes plus. So you get 1/3 times, and now we're ready for that antiderivative. The antiderivative of x is x squared over 2 minus 3 times the antiderivative of x squared happens to be x cubed over 3. You evaluate this from -1 to 2. And let's just go ahead and make this look pretty on one more step, and then we'll use Desmos. 1/3 times 1/2 x squared. On this one, your 3's will cancel. So you'll just be left with -x cubed from -1 to 2. Now again, that's perfect for shown work. Now let's just type this in the calculator. Okay. So I get 1/3 times the integral from -1 to 2 of x minus 3x squared dx. And there it is. We get an answer of -2.5. Okay. Now let's go ahead and graph the function. So here is the graph, and we're graphing y equals x minus 3x squared. And it's giving us the interval from -1 to 2. So once again, it's telling us what x values to use. So when I draw my graph, here's -1, there's 0, there's 1, and there's 2. And now, again, I'll use Desmos to find those y values, x minus 3x squared, use that table feature, and type in the x values, -1 to 2. Okay. There we go. All right, -1's there already. Hey, they're all there. -1, 0, 1, 2. So we get -4, 0, -2, -10. So that means down here, I'll say that this is -4. So this would be -2, -4, -6, -8, -10. There's 10. There's -2. And let's plot it. At -1, we're at -4. 0, we're at 0. 1, we're at -4. No, sorry, -2. And then 2, we're at -10. So we're down here. So our function looks like this. Let me get rid of that dot. Oh well, there we go. And all we have to do is graph the average value, which happened to be y equals -2.5. So if there's -2, -2.5, somewhere around here, and there it is. There's the average value line. Okay. Not bad. Any questions on that? All right, we're good. keep moving. Okay. 3. F of x equals the cube root of x from 1 to 8. So again, let's set up that integral. Here's a, here's b. And we get 1 over 8 minus 1 times the integral from 1 to 8 of the cube root of x. So since this is a cube root, we have to rewrite it as a power. So it's going to be x to the 1/3 dx. Okay, there it is. It's set up, which means we can find the antiderivative by power rule. So this is going to give me 1 over 7 times, and this will be x to the 1/3 plus 1 over 1/3 plus 1 evaluated from 1 to 8. Okay, so just a little cleanup here. We get 1/7, and this is going to give me x to the 4/3 over 4/3 evaluated from 1 to 8. And one last cleanup. We are going to flip that denominator and get 1/7 times 3x to the 4/3 over 4 evaluated from 1 to 8. Hey, Desmos time. There we go. So I'm going to go back up to the top, and that's what I'll type in. I'll say 1 over 7 times the integral from 1 to 8 of x to the 1/3. And then, of course, with respect to x. And there we go. We'll do the 2 decimal places. I get 1.61. All right. And now graph it. Let's say graph. And we are graphing y equals the cube root of x. Here's my xy chart. And once again, it tells us what x values to use. It says use the values 1 to 8. So here's 1, and then 2, 3, 4, 5, 6, 7, 8. Now Desmos, I'll type in the cube root of x, or have it as x to the 1/3. And now do the xy chart and type in the values 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So looking at these y values on the left side, the only clean ones are 1 and 2, and that's technically all we need. So over here, I have 1, and over here, I have 2. So 1, 1, and then 8, 2. So my function would curve up just a little bit from there to there. And then all that's left is graphing the average value, which is y equals 1.61. And that's going to be, we'll just place that a little above the middle between 1 and 2. And there we go. There's our average value line. Okay. And I don't think any more graphing after that. Cool. All right. Everybody okay with those first 3 examples?
Yes, sir.
All right. Thank you. But at least send a thumbs up if you want. Let me know somebody's out there. Okay. Number 4, same thing. This time we don't have to graph. Given the demand function, find the average price in dollars over the demand interval 500 and 900 of d of x equals 3,000 over x. So they're giving us a function, they're giving us the interval. So now let's set up the integral. So we're still finding average value. Okay. So here's A, here's B, and we get 1 over 900 minus 500 times the integral from 500 to 900 of the function 3,000 over x dx. Okay, so for this problem, we're actually going to clean up the integral a bit before moving on, because I know there's a problem like this on your homework where it wants you to actually set up the integral. So let's go ahead and do that before we find the antiderivative. So this will give us 1 over 400 times the integral from 500 to 900 over 3,000 or of 3,000 over x dx. So what this problem wants us to do, which is whatever, it's my MATLAB, is you're going to multiply this fraction inside. So we're going to put the numbers together. Okay, so this means that if you multiply the 1 over 400 inside, you'll get the integral from 500 to 900 of 3,000 over 400x dx. And now all we're going to do here is just simplify 3,000 over 400. So I got a calculator over here on the left side. Why not? 3,000 over 400 leaves me with 7.5. So you'll get the integral from 500 to 900 of 7.5 over x dx. We're not done, but I'm boxing this because on the problem it says set up the integral, and it wants you to type this in exactly.
Quick question.
What's up?
Sorry. How did you get to the 7.5? Is that just by dividing or?
Yeah. You see on the left side of the screen, what's 3,000 over 400?
Got you. Okay, sounds good.
All right. Okay. Now let's find the antiderivative and plug these numbers in. So what we're going to do again is just rewrite this. I'm going to take that 7.5 out now. And you'll have 7.5 times the integral from 500 to 900 of 1 over x dx. And now we know that the antiderivative of 1 over x is the natural log of the absolute value of x. So this will become 7.5 times the natural log of the absolute value of x evaluated from 500 to 900. And now let's go ahead and plug in the calculator. We're actually going to plug in the calculator what I boxed in purple. So you're going to have 500 to 900 of 7.5 over x dx. And rounded to 2 decimal places, we get 4.41. And this would be the average value, or depending on what the problem said, this is your average price in dollars on this interval. So 4.41 is your average price. Okay. Don't have to graph this one. But again, the problem in your homework is going to say set up the integral, and what I boxed in purple is should be your answer. Okay, all good?
Yes, sir.
Yes.
Okay, cool. All right. Again. All right. 5. Given the price supply function, S of x equals 8 times e to the 0.05x minus 1, find the average price in dollars over the supply interval 40 to 50. So again, same exact thing. Let's find the average value. All right. And for this antiderivative, we're going to use that new formula that's on the first page. I'll just rewrite it here so we remember. So it was the integral of e to the ax dx gives us 1 over a e to the ax plus c. So that's a new formula. So we're going to use that for this problem. Okay. So setting up this integral, here's a, here's b. So we're going to get 1 over 50 minus 40 times the integral from 40 to 50 of 8 times e to the 0.05x minus 1 dx. Okay, let me make sure I wrote down that problem right, and I did. Okay, so let's go ahead and clean this up a bit. Let's make it look pretty before we find the antiderivative. You'll get 1 over 10 times the, actually, what I'm going to do is take this 8 and move it to the outside of the integral. So instead of 1 over 10, we're going to have 8 over 10 times the integral from 40 to 50 of e to the 0.05x minus 1 dx. So all I did was take that 8 and move it outside. Okay, now we are ready to find the antiderivative, and we can reduce that 8 over 10. That should reduce to 4 over 5, bracket. And now here's where we use that special formula above. So the antiderivative of e to the 0.05x is going to be 1 over 0.05 times e to the same exact thing. There's that. Minus the antiderivative of 1. 1 is a constant, so it's going to be minus x. And we evaluate this from 40 to 50. And now calculator time. Oops. Get rid of that, get rid of that. And here's what we're going to have. I'll just have it as 1 over 10 times the integral from 40 to 50. Or should I do 8 over 10? I should do 8 over 10. 8 over 10, there we go. And then parentheses, e raised to the 0.05x minus 1 with respect to x. And there it is. We get 68.69, 68.70. There's that 5 right after. And done. And that is going to be our average price. All right. Everybody good with that?
Yes.
Do we need to graph it here as well?
No, no more graphing.
Okay.
Those graphing on the first 3 problems, I think. That was it. I'm not sure if your homework makes you graph it. It might. That's why I showed those on there. Or if you happen to hit the help button, I think if you hit the help button, it'll make you graph it.
Okay.
Yeah, so that's there for a reason. All right, I think we're on the last one. Cool. All right. So average cost. The total cost in dollars of printing X dictionaries is C of X equals 20,000 plus 10X. Find the average cost per unit of 1,000 dictionaries are produced. There's the formula for average cost. B, find the average value of the cost function over the interval 0 to 1,000. And then C, interpret all results. Okay, so for step A, we're going to find the average cost function. So we learned this back in 1324. We've seen it before. Average cost is given by the formula C bar of X equal to C of X over X. So all we have to do is take the cost function that's above and put it all over X. And then we're going to plug in 1,000. Okay. So let's go ahead and do that. So step A, we're going to find the average cost function, which is given by C bar of X. And that's going to equal our cost function, which is 20,000 plus 10X. I don't think I just need the calculator part. There we go. Nope. Okay, perfect. All right. 20,000 plus 10X. There's average cost. Now all we have to do is plug in 1,000. So C bar of 1,000 is equal to 20,000 plus 10 times 1,000 over 1,000. Okay. And now, just as I wrote it below, I can type it exactly like that in Desmos. So I'll hit the little division button, and I have 20,000 plus 10 times 1,000 over 1,000. And we get the average cost of producing 1,000 dictionaries, or I guess it's going to be the average cost per dictionary, is going to be $30 per dictionary. I'll just say book. Okay. So that's average cost. So if we're going to produce 1,000 dictionaries, it's going to be on average $30 per book. Now B says find the average value of the cost function over the interval 0 to 1,000. So now we're going to set up an integral for our cost function. Okay. So B, we're finding average value. So from the interval above, A is 0, B is 1,000. So we get, I'll just say here, average value, and we're going to get 1 over 1,000 minus 0 on the integral 0 to 1,000 of our cost function, 20,000 plus 10x dx. Okay, there it is. Our integral is set up. Let's go ahead and find the antiderivative. It's ready. So the fraction 1 over 1,000 minus 0 is 1 over 1,000. Put a bracket to be neat. And now we can find the antiderivative of the function. The antiderivative of 20,000. 20,000 is a constant. So that's going to be 20,000 x. Plus the antiderivative of 10x is going to be 10 times x squared over 2. And we evaluate this from 0 to 1,000. Okay. One last cleanup. Just want to make it look pretty before we plug everything in the calculator. 1 over 1,000 times 20,000x plus 5x squared evaluated from 0 to 1,000. And now calculator. So here we go. 1 over 1,000 times the integral from 0 to 1,000 of 20,000 plus 10x and then dx. And we're going to get that the average value of producing 1,000 dictionaries is $25,000. Okay, so this is the average value. So when we say interpret the results, well, if we make 1,000 dictionaries, it should cost around $30 per book. But then altogether, for the average value, if we're gonna make 1,000 dictionaries, then that cost should come around $25,000. So there's a little difference. Maybe we thought it would be 30 times 1,000, so it would be 30,000. But of course, there could be other factors at play here. So as long as those are in the area. So again, if we make 1,000 dictionaries, it should be around $30 per book. And if we're gonna make 1,000 dictionaries, then the average value will be around 25 grand. And there you go.
Does it
That's
ever tell
it.
us what those factors are?
No, I mean, we don't get into that. Like, I guess, assume you ran a dictionary printing business, right?
Mhm.
Maybe you were making money on selling dictionaries, therefore your cost would go down.
Okay.
So it's a bunch of those factors. So I guess it just makes you think, but other than that, we don't go much further other than plugging numbers in. All right. Other than that, we're done.
Okay, thank you.